Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
In early 1990s lectures that I delivered as the distinguished speaker from the Computer Society of the Institute of Electrical and Electronics Engineers and from the Association for Computing Machinery, I said, the central processing unit of the computer reduces the infinite arithmetical calculations as defined on the blackboard and reduces it to the finite floating point arithmetical calculations as executed on each motherboard. The parallel processing brain of my new internet is my new global network of 2 raised to power 16 or 65,536 central processing units. I visualize those electronic brains of my new internet as positioned at the 2 raised to power 16 vertices of a cube in a 16-dimensional universe. I visualize those electronic brains as having a one-vertex to one processor correspondence with the as many vertices of the cube in that 16-dimensional universe. The email wires of my new internet were 16 times 2 raised to power 16 or 1,048,576 bidirectional email wires. 32 email wires fed electronic messages that comprised of the initial and boundary conditions for my system of partial differential equations and fed those answers directly to each central processing unit. I visualized my emails as 5 subject-lined email messages, each synchronously sent to each of those 65,536 central processing units. I visualized my 65,536 synchronously sent 3 subject-lined replies that I received from each of those 65,536 central processing units. As a research mathematician of the 1980s in College Park, Maryland, my motivation for solving this grand challenge problem was this. I discovered 36 serious errors in the system of coupled nonlinear, time-dependent, and 3-dimensional and 3-phased partial differential equations of calculus that is used by Exxon Corporation, Mobil Corporation, and used in petroleum reservoir simulators and used to simulate multiple what-if scenarios of how to discover and recover otherwise elusive crude oil and natural gas. I am the research mathematician that was cover stories in top mathematics publications, such as the June 1990 issue of the Siam News. The Siam News is written by research mathematicians for research mathematicians. I was cover stories because I discovered that the fundamental partial differential equations printed in the calculus textbooks that were used by the petroleum industry were erroneously formulated. The mathematical physics errors that were that the temporal and the convective inertial forces that existed on the storyboard or inside the oil field were missing Those errors corresponded to the 36 partial derivative terms of calculus that encoded them on the blackboard and algebraically coded them in the motherboard. That egregious mathematical error in turn meant that the sum of the three forces, namely pressure, viscous, and gravitational forces, within the petroleum reservoir simulator cannot be equal to the sum of the four actual physical forces, namely inertial, pressure, viscous, and gravitational forces that exist within the production oil field. Metaphorically speaking, petroleum reservoir simulators were built on sand, not on oil sand. And equations built on sand produces abstract verbiage and circles of errors.
Insightful and brilliant lecture.